Hello everyone. Today what I'm going to be doing is creating an echo using the impulse response in MATLAB. And for that I have broken my work into few tasks. First I'll be loading the audio in MATLAB and then I'll play that sound for you. Then I will develop an impulse response for the echo, and we will be doing some convolution for that uh, by convolving the input signal and the impulse signal to give you the final output result. And then I will play the echo effect that we will create. Now as we move on, I will talk about convolution and the impulse response, but it will just be an overview and not much in detail. So let's move on to our first task, and that is loading and playing the audio. So for that we have a function called audio read, and basically here f and f of s. Fs is basically a variable which gives you the sampling frequency of the audio you're loading, and f is basically that audio or those samples. So let's load the audio. Now when you're loading the audio, make sure that you are present in the folder where the audio is located, or that audio is present in your current directory. Otherwise you won't be able to find it, MATLAB won't be able to find it. Or you can either just point it towards where the audio is located, but I rather found it easily putting it in my current directory. So we do this function and we have created f and f of s. Now I'll play that sound for you. So basically for that it's sound f of s.
A wizard is never late, Frodo Baggins. Nor is he early. He arrives precisely when he means to.
Yes, from the Lord of the Rings. Now moving on, we have to develop the impulse response for echo. Now what is an echo? Echo is basically when you listen to your sound again with a lesser amplitude. Now lesser amplitude is not the condition, but when you do it in a natural environment, for example in an empty room or a mountainous area, the sound reflects back and you hear your own sound again, or the sound you are playing and you hear it back after a delay. So that is simply an echo. Now to to create the echo effect, we have to perform convolution between the input signal and our impulse system. Basically, convolution is a mathematical way of combining two signals to form a third signal, and we are going to be convoluting the input signal and the impulse function. Now what is an impulse function? Impulse function is basically a function, and let's say it is an array which is 1 at the origin but it is 0 everywhere else. And an impulse response is when you input a signal and you pass it through a system, an impulse system. So what you get in return is your impulse response. What I am here trying to say is basically that your output signal y of x is the output signal is basically when your f of x is your input signal and h of x is your impulse response. You convolve both of them and what you get is a y of x. So when we are talking about an impulse response, what we are saying is that we play or we repeat the signal. Basically what you just input, it gives you the same exact output without doing any changes to it, right? So basically my output is basically equals to my input, and for that the h of x, which is gonna be my impulse signal, is basically the direct signal, direct impulse, which is 1 at the origin and zeros everywhere else. So basically when you input a signal in an impulse system, so as soon as the input signal passes through the 1, you hear that sound again, and when it obviously it is passing through 0, you do not hear that part. So when it is passing through 1, you hear that sound again. Let's show you a simulation. Basically, let's say if this is my input signal and this is my impulse system. So when it is passing through zeros, you can see there is no output. Now as soon it will start passing through 1, you can see that the function has repeated itself. And what happens in an echo is basically that this signal, you hear it again. So basically I can say that there is an impulse response, another impulse response after a delay, right? And maybe lesser in amplitude. So what you hear is that you start hearing the sound again, and that is your echo. Moving on, I hope you have understood what I'm trying to say. Otherwise you can read more about convolution on internet. Now what we need to do is create the impulse signals, right, that we will be using for our echo effect. Now when I talk about delay, what I'm basically saying is that if there was a 1 at an origin, and then now I'm saying that there is another 1, or maybe a 0.5, right, which halves the amplitude of the input signal after a delay. So basically delay is the tau, and here we are talking about discrete samples. We have uh, if I go here and show you size of f, so it's basically 90,951 sample. So what I am gonna be doing is that I want to create an impulse which is which repeats itself after a delay of 1000 samples, right? So for that I am putting tau is equals to 1000, and now we'll be creating our impulse signal. So the first signal, which is basically just repeats the same signal which we saw in the simulation also. It's basically it's 1 at the origin, and then there are zeros. Basically zeros is the function in MATLAB which you use to create an arrow of zeros. So basically for next 1000 samples it remains 0, and for another 1000 samples it remains 0. Now it is understood that if I write here 1, then it's just 1, and if there are no other numbers it's going to be 0. But why I am writing it is because when I create the impulse signals for my delay, I want those signals to be of same size, so I can add them up and then we can convolve it, right? So what here you say there is what you see here is 1, and then all other zeros, and then there is another impulse signal which is 0 for the first 1000 samples, and then there is one sample of 0.5. Basically it is reducing the amplitude to the half, and then there are another zeros, 1000 zeros. and similarly a third impulse signal which is 0 for the first 2000 sample, and the third sample is basically 0.25, right? So basically by doing by putting these zeros like this, what I've done, and putting these zeros here, what I've done is created impulse signal of the same size, so I can easily add it up. So I'll just copy paste this into MATLAB. So you can see we have created matrix of the same size. Now we have h and h of 1. Now I would like you to see something. If I plot my sound, this is what it looks like, right? Similarly, if I plot, I can also plot these impulse signals. For that, I will hold on. Now I want to plot h1, h2, h3. So what basically we're seeing is that at a 0 there is an impulse function which has a unit of 1, and then after a delay of 1000 samples there is another impulse, but it is half, basically reducing the amplitude, and then another one after another 1000 samples. So when the audio signal will pass through this, when it will pass through this, it will create an exact same sound, and then another sound will occur when it will pass through this impulse function, and then another one through this impulse function. Obviously you will hear the same sound again, because once it passes from here, then it passes from here again, but with a lower amplitude. And similarly for the third delay. So now what we gotta do is do convolution, simply, for which we have the MATLAB function of conv, and we can simply copy paste it, and now play the convol function for you. So basically now y is our convoluted function. Let's listen to the original sound once again, so you can remember the difference. I want the sampling frequency to be there.
A wizard is never late, Frodo Baggins. Nor is he early. He arrives precisely when he means to.
And again, now with the echo.
A wizard is never late, Frodo Baggins. Nor is he early. He arrives precisely when he means to.
I hope you were able to hear the difference, because I'm not sure, because of the application I'm using for screen recording. It does not record the audio very well. You can play it in your own computer and see the result. So basically what we did here was loaded an audio file, then we created some impulse responses for that echo, and then we heard the echo. So that's all. Any questions, any comments, you can put them in the comment section, and I will answer them for you. Thank you very much.